Hello everyone, welcome back to my channel. In today's video, we are going to talk about tautology. For here, previously we have discussed about logics under preposition, conditional, biconditional, or an AND gate. So here, for tautology, it's a combination of all those aspects we have covered previously. But here in tautology, the variables must be true for a statement to be a tautology, okay? So here you can see we have an example here, two examples on the board, which says construct a truth table, and hence prove that is tautology or not. Is tautology or not. So now let's see. From this example, let's try to construct a truth table. But first, I want to give you a simple logic on how you can know the number of rows and columns you are going to construct. More especially, let me give you a simple formula here. 2 to the power n. So first, this n stands for the number of variables given, or the inputs. You can say the inputs or the variables given. Here you can see for this first example, the first variable here we have is p, the other variable is q, and the other is r. So the number of variables we have here is 3. Okay? So since the number of variables is 3, we are going to construct a table that entails 8 rows. 2 to the power 3 gives you 8. So now let's first say P, Q, and R. These are our basic truth table. Oh, I hope the space we can manage here. So here we have false, 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 then 2, 2, 2, 2. As you can see, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. Because we have 3 variables given. Okay? We check from here P, Q, and R. Mind you, here is Q, but we already have Q here. So no need for us to repeat the Q again. Then here, false, false, 2, 2, false, false, 2, 2. And here we have false, 2, false, 2, false, 2, false, and 2. Okay? So now we can see from this table we have here OR gates. Previously we discussed about OR. This is OR, this is AND, this is negation. We have treated about all this one. And this is biconditional. Okay? So now first, if you want, it depends on you. If you want, you can start from this, negation R, or you can start from this one, P or Q. Okay? After which, you combine these two with AND gates or AND symbol. Okay? So first, let's start with P or Q, or you can start with this one. So P or Q. For all statements, it says what? This one can only be true if any of the statements is true or false. But if both are false, then it's if both statements are true, then it's true. It can only be false if both statements are false. Okay? So now let's see P or Q. Here in this table, we are going to consider only P and Q. We exclude R. Okay, so here we can see false, false here become false, false, false here again becomes false, false 2 becomes 2, because if one of the statements is true, then it's true. So this one becomes true, this one becomes true, this and this becomes true, this and this becomes true, this becomes true, and 2 becomes true. So now we are done with this first OR gate. So now let's come to negation R. Negation simply means not. So if we have here like false, negation of this false will be true. So let's see here. This one becomes true. This one becomes false. This becomes true. This becomes false. This true. This false. This true. And this false. Okay? So now you can see here we have these two, 1 and 2 has already completed. So now let's try to combine these two using this AND gates, okay? AND sign. So now P or Q and not R. So let's see, now we focus on these two. But for AND says what? If the statement can only be true if both statements are true, okay? Otherwise, it's false. So it means if you have zeros or false, two false statements become false. But if one of the statements is true, if we combine these two, if one of the statements is false, it becomes false. It can only be true if both statements are true. That's for this AND. So now let's consider these two columns. We see false and true becomes false. False and false become false. True and true becomes true. True and false become false. True becomes true. True false become false. True becomes true. And true false become false. So now we are done with these two. So now let's come to this biconditional statements. From our previous video, if you never watched the previous video, make sure to check that video, okay? Because there we treat about biconditional. So now we combine this to this biconditional statement. Let me just label this as 1 for it to be simple. The whole of this set here is 1. And we combine it to this one. So we say 1 bicondition Q. Okay, so for biconditional statement, it says what? This statement can only be true if both of the statements are true or false, it becomes true. But if they have differences, like the one is true, the other one is false, then it becomes false. Okay? So now let's see. We'll combine this one to Q. We'll check here Q. Let's say Q is 1, this is 2. We'll combine this 1 and 2. We'll compare 1 and 2. If both statements are true or false, it becomes true. Otherwise, false. So now let's see, false here becomes true. False, true here becomes true. True here becomes true. True. For true, false here becomes false. False, true here becomes false. False here becomes true. True here becomes true. And true, false becomes false. So hence, for this example, hence, this statement is not a tautology. Okay, so for this statement, from this one here, we prove that this statement is not a tautology. So let's see the other example, but because of space, I need to remove this one, then we'll continue. Just make an. So now let's try to solve this other example. Let's see if this one is a tautology or not. Okay, we'll start by counting this number of variables here. So the number of variables in this one is the same as this previous example. P, R, and Q. So we have 3 variables. Okay? So we start by constructing our truth table. First we have P, Q, and R. Okay? So again we start from false, 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 2, 2, 2, and 2, false, false, 2, 2, false, false, 2, 2. Okay? False, 2, false, 2, false, 2, false, and 2. So here you can see we have conditional. Conditional, this one is not biconditional. For conditional statements, this antecedent or the premise, if this antecedent or premise is true, and what the consequences or the conclusion is false, then we have false. Otherwise, it's true, okay? Only one condition that will give us a false value. If the antecedent is true and the consequences or the conclusion is false, then we have false. Otherwise, everything becomes true. Okay? So here we can start by constructing this table from this P implies R. Okay? So let's compare P and R. P implies R. This one becomes 2. This one becomes 2. This one becomes 2. This false and 2 becomes 2. 2 and false become false. 2 and 2 becomes 2. 2 and false become false. 2 and 2 becomes 2. Okay? Now, we'll check for P implies R. Implies R. Q implies R. Okay? So for Q implies R, we apply the same as this one is conditional. Okay? So false 2 here becomes 2. False 2 becomes false, false becomes 2. False 2 becomes 2. 2 false becomes false. 2 2 becomes 2. False false becomes 2. False 2 becomes 2. 2 false becomes false. 2 2 becomes 2. So let's check this once more. False false becomes 2. False 2 becomes 2. 2 false becomes false. 2 2 becomes 2. False false becomes 2. 2 false 2 becomes 2. 2 false becomes false. 2 2 becomes 2. Okay? So now let's try to combine these two using AND. Okay? P implies R and Q implies R. So for this AND symbol, we can only have 2 when both statements are true. Otherwise, it's false. Okay? If both statements are true, it's true. Otherwise, everything becomes false. So now let's see here. 2 2 becomes 2. 2 2 becomes 2. 2 false becomes false. 2, 2 becomes 2, false 2 becomes false, 2, 2 becomes 2, false, false becomes false, 2, 2 becomes 2. So we still have here P or Q. P or Q. So for the OR statements, if both statements are false, it becomes false. Otherwise, everything is true. So let's see P and Q. False, false is false. False, false here is false. False 2 here is true. False 2 is true. True, false is true. True, false here is true. True, 2 is true. And here 2, 2 is true. Okay. So now we are done with this one. Now this P or Q implies R. P or Q implies R. P or Q implies R. Here is R. That this is our P and Q. For the implication conditional of this R, it can only be true if this antecedent is true and what the consequence or the conclusion is false. Okay? So let's see R and this, we compare. This is, okay, let me just simplify this one. This is our premise or antecedent. And this is our conclusion. Okay? So this implies this. This implies this. So we'll come this way. False, false becomes true. False, 2 becomes true. True, false becomes false. True, 2 becomes true. True, false becomes false. True, 2 becomes true. True, false becomes false. And true, 2 becomes true. So now we try to combine this one and this one. Okay? Let's label this as 1 and this as 2 because of space. Okay? So we combine these two. 1 implies 2. This is 1 and this here is 2. Okay? We move this one. We don't need this one again. So let's compare this and this using conditional statements. So for conditional statement, if the premise or the antecedent is true and the consequence or the conclusion is false, then it's false. Otherwise, everything becomes true. Okay? So true, 2 here becomes true. True, 2 becomes true. False, false becomes true. So false, false is true. True, 2 is true. False, false here is true. True, 2 is true. False, false is true. And true, 2 is true. Hence, for this one is a tautology, okay? Because as you can see here, all the variables becomes true. Okay? So here brings us to the end of this video. Don't forget to like, comment, and subscribe on the channel.